All right, today I want to talk about projectile weapons. Um, with projectile weapons, and a projectile weapon is one that throws a rigid body that then follows some parabolic path. And unlike the laser weapons that shot a beam of light that was kind of instantaneous and wasn't affected by gravity, these are sometimes tough to aim. And so the goal here is to have an aiming reticule similar to what we had with the laser weapons. And reticules, of course, are easy to set up. A sprite texture, such as this little green circle, as an image UI, positioned with a small enough width and height to make it interesting in a screen space overlay canvas. Now, our goal to have our projectile hit the point that we're aiming at requires that we do a little bit of physics. In uniform gravity, which is what Unity's default gravity is, 9.81 meters per second squared in the y direction, the horizontal and vertical components of the object's equations separate. If we think of the horizontal as x and z, where there's no acceleration, it's just, it's moving with a constant velocity, our position is given in terms of its initial position and its initial velocity as just x0 plus v0 times t, same in the z. In the y direction, where there is gravity, where there is an acceleration, the velocity is no longer uniform. But we know from integrating F equals ma that the position as a function of time depends on its initial position, its initial velocity times time, and that acceleration 1/2 gt squared. So our goal here in hitting a target is to know what x, y, and z0 have to be in order for it to go from x, y, z0 to the target x of t, y of t, and z of t. Because this parabolic path is a plane, we only really need to think in 2 dimensions. We have the horizontal x and z displacement and the vertical y displacement. So in a way, what we're thinking of is the speed and angle that we have to launch our projectile at in order to hit a particular target. So if I go back to these equations and I solve them for the velocity that I need, VH in the horizontal and VY in the vertical, I have very simply that the horizontal velocity has to be the change in position horizontally divided by time, and solving for Vy here, Vy is going to be the change in vertical position over t minus 1/2 t. When we divide through by t here, one of these t squareds disappears. So what we need here to specify this is the time of flight, t. Now, I have a function throw velocity that calculates this, the given velocity, the velocity that I need to get from the origin to the target. And I'm going to define a kind of nominal projectile speed. The ultimate speed may be different. And form a vector between my target and my origin. And with the magnitude of this vector, that is the distance, divided by this nominal projectile speed, I get a time of flight. Now, the vector to target xz is just the vector to target with its y component zeroed out. So the magnitude of this vector, I'm calling it xz, is that change in horizontal position, the delta h from up here. The y, which is just the target to target dot y, is the change in the vertical. So I have here that v0y is y over time of flight plus 1/2, and this is g, t, and the velocity in the horizontal is just that horizontal distance over time of flight. So quite simple. So I form a vector result that is in the horizontal direction of to target xz, and I normalize it so that it's a unit vector. I scale it by the horizontal magnitude that I want, v0 xz, and then I replace its y component with v0 y. And I can form the speed as its magnitude and the angle from a little bit of trigonometry. I'm not actually using them in the projection, but I have them there for diagnostic purposes. And I'm going to return that result. Now, when it comes time to fire the projectile, we instantiate it, we get its rigid body, and we use the add force at the gun tip's position using a particular force mode, the velocity change force mode. And this one from the documentation says that it adds an instant velocity change to the rigid body, ignoring its mass. So this basically instantaneously sets my rigid body's velocity to be in the throw velocity direction and magnitude. And I have a sample scene where I have a little character wired up to do just this. And so here I can point my reticule at some target and press the fire button, and it automatically calculates a speed of 52.28 and an angle of 16.99 with a time of flight of 3.06. If I don't have a target, it's just going to fire that missile at that nominal speed with the angle of the gun. So it's not actually aiming at a target here. It's just kind of firing it off into space at the angle provided by the gun. But if I'm aiming at anything in particular, it's going to calculate those positions and send things off in such a way that it hits the targets. I've got a little probe object here that I'm putting out into the world where the target's going to hit. That's just for diagnostic purposes. So, that's all pretty simple. Somewhere I stumbled on a character, the archer, who has this really nice draw arrow and shoot animation that I thought would be perfect for this. So my little archer has this archer attack animation, which when you play it, he takes an arrow out of his quiver, draws the bow back, and fires the arrow. And so I thought this would be perfect for a projectile. I need a motor to drive him around that interfaces with this targeting system. And unfortunately, the animations don't have root motion, so I have to use a character controller move function to drive the character around. If you look at his run animation, there's no root motion here. He runs nicely, but we're going to have to tune that up to make the footsteps match and so forth. I'm going to use the idle, the run, and the attack that has this nice draw, arrow, and shoot. There's also a hit and a die animation I'm not using. After fiddling for a while, I decided to have my archer align with the camera view, and then all I had to think about was movement forwards and backwards. And so my little character, automatically aligns with the direction that my camera is facing, and he runs forward. And I actually have him run backwards too. And there is a strafe option, but I haven't bothered to set up an animation for strafing. The other thing is I wanted to use the Cinemachine camera system with a main camera that's controlled by various virtual cameras. And this is going to allow us to change the camera angle as the player is aiming. And I can show you this. Here are my different camera systems. Whoops. Here are my 3 cameras. I have the main camera, which is the real one, and then 3 virtual cameras, aim, normal, and tunnel. Aim is kind of a very narrow field of view, so telephoto kind of lens. It has a very small aperture here. It's focused onto that single point. Normal is the over-the-shoulder one. By offsetting this area of the camera where I'm going to keep my character means my camera will always be kind of off on the right. And then tunnel is just the same kind of camera except centered on my character. I'll show you what that's for later. Notice with both the tunnel and the normal, I've got a bit of noise here so that it jiggles around. I'm using a noise module down here somewhere for these cameras. So the motor is going to use these, but I'll get to that in a minute. And so in the motor, I'm going to catch my camera, my main camera, the actual camera. I've got this Boolean fired that is a public variable. I'm going to set it from another script. I'll show you that later. And I'm getting copies of the animator that I'm going to set various parameters on, and my character controller that I'm going to use to move the character. The public variables trigger and fired will set elsewhere when we're going to handle the attack. So in terms of the movement, I'm basically using horizontal and vertical axes as V and H. I'll show you the attack stuff in a minute. And here I'm setting the animator speed to be the vertical axis and scaling them by run speeds and time.delta times to get uniform movement. I'm getting the camera's forward vector, setting its Y to 0, forming a rotation that looks in that horizontal XZ direction, and then assigning that to my transforms rotation, forming a desired vector that includes the forward and the right, that's the strafing, and then the gravity times the vector up to suck my character down. That's because I'm using a move instead of a simple move. Now, what went in this attack stuff? If the trigger is true, that means I've started the attack, and fired is false, which means I have not already started attacking, then I'm going to turn my camera to look at a target, which I'll find by doing a ray cast out into the world. And I'm going to look at that target that I've hit, the hit point, and I'm going to set the Boolean in my animator for fire to be true. So this is going to trigger the transition from whatever I'm in into the attack animation. Otherwise, I set it to false. Now, the reason that I'm doing this is that I'm going to use a state machine behavior that is triggered when we enter the attack state. If we look at our controller for the archer, the controller for the archer here has the attack state, the archer attack, and it comes from any state, and when it's done, it goes back to idle. And it has this fire projectile state machine behavior on it that has the exposed variable, the probe. That's that little thing that I'm dropping in place here. So the state machine, here's the probe and the various privates that I'm going to use, many of which are similar to what I've done in that first case with the first person. So a state machine behavior has three key functions. There's on-state enter that triggers when we enter the animation. There's on-state update that is triggered every cycle while we're in the state. And there's on-state exits that's triggered as we leave it. So as we come into the attack on enter, as we're in this executing it, we're doing the update. And when we exit it, we'll call the on-state exit function. So on-state enter catches the camera. It sets fired to be false, and it puts that on the motor. It gets its transform, that's the motor's game object transform. It gets the gun tip off the motor, it gets the projectile off the motor, and it gets the projectile speed off the motor. All of these things stored in the motor. And here it's setting that fired to be the result of the calc velocity function. Now, what calc velocity does is array cast. If it doesn't have a probe yet, it instantiates one and puts it at the hit point. Otherwise, if it's already made it, it just puts it at the hit point. It then sets the origin to be the gun tip position, the target to be the hit point, and it calls that same throw velocity function that I showed you before that calculates the velocity, the angle and speed that is necessary to exactly hit our target. It also gets the XZ component of that by Ying out this copy of it, getting the projectile speed and a rotation that looks in that direction. And if it has hit something, it returns a true. Otherwise, it returns a false. And back here, whatever is returned there is what we're setting motor fired to be, the fired variable in the motor script. And remember, if it hasn't fired, it is eligible to. So the throw velocity is pretty much all the same as before, except here I'm assigning speed and angle on the motor and time of flight on the motor. This is not something that's used by the motor, but the UI display is being done in the motor, and so I'm returning those values there. Now, on-state update. This is the one that is triggered every frame that we're in this animation, and we look at the current time, which is a normalized time. It goes from 0 to 1 over the animation's runtime. So at the beginning, current time is 0. When the animation is done, current time is 1. And experimentally, I found that 0.55 was the time in the animation that corresponded to the point at which the arrow was released. So each update here, it's checking the time. As long as it's less than 0.55, it does nothing. But if it's greater than 0.55 and it has not fired yet, then it sets fired to be true. It instantiates the projectile. It gives it the add force, and it goes on. Now that fired's true, it's not going to do this again. So it won't repeatedly do this. This not fired prevents it from firing repeatedly. And finally, in the on state, we're going to reset fired back to false, both here and on the motor, and then we're done. Now, going back to the motor script, where now that the trigger is true and we have not fired, we can set the trigger. We can look at the target and start the animation, which triggers all of that stuff that we just looked at. We're ready to go. Now, the last thing to deal with here is the virtual cameras, because I want them to also kind of participate in this. What I want to have happen is I want to when I press the fire button here, I want A, my reticule to appear. I want B, it to zoom to the aiming camera. And when I release it, it's going to go back to the over-the-shoulder camera and release that, that bullet at the right time. Incidentally, let me go over here and show you what I want to do with the tunnel. I've got this big tower of blocks that I'm going to knock down. And the problem is with that over-the-shoulder camera, when I'm in here in the narrow passageways, it's kind of difficult to navigate. And so by toggling to that straight behind camera, I get a camera that makes it easier to navigate these narrow passages. And just for fun, there's a bomb in here that blows the whole thing up. And I've got a light that I can illuminate so that I can now walk around in this ruined pile of blocks and find some treasure or whatever it is I'm after. So I have the three virtual cameras: the normal camera that is an over-the-shoulder, the tunnel camera that is straight behind, and the aim camera that is zoomed in and moved forward so that we don't see our character. And I'm going to control these through their priority. So to begin with, aim and tunnel have a priority of 9, and normal has a priority of 10. So normal is the camera that will by default be active. On the aim camera, I have an activate on key press script. And two things this shows you: one, how to access the Cinemachine virtual cameras, as well as a little trick with a key code that we can set from the inspector. Like many of the camera scripts, they extend some base class. And in this case, the Cinemachines all extend the Cinemachine virtual camera base class. So my virtual camera is a Cinemachine virtual camera base object. And here I get that component. In the update, I'm going to watch the get key down and get key up. When I press the key down, it's going to boost the priority of my camera right here. If it's not already boosted, I'm going to boost it, and I'm going to set the Boolean to be true. This kind of keeps me from flogging on the get key down button. When I release the key, get key up, I'm going to set the priority back to what it was before so that it goes back to the normal camera. I'll set boosted to false. And here's where I'll trigger the motor that starts that whole attack sequence. So I'm setting the exposed variable on the motor trigger to be true. And if you recall, that's what begins the whole animation sequence and the firing of the projectile. I'll also turn on and off the reticule in here with just what the set active boosted. And I showed you the business of navigating in amongst the narrow passages where the normal camera didn't work. And so that has another script on it. The tunnel camera has the toggle on key press. That's very similar to activate on key press, except in this case, it toggles the boostedness and then sets the appropriate priority to raise or lower it. So this one now is permanent until you press that key again. Pressing the fire button zooms and releases when I let it go, whereas the toggle key toggles back and forth between the over the shoulder and the directly behind setup. That pretty much settles it. There were a couple of little tricks here. With the Archer, I can't actually shoot into the sky. It has to have a target. for it to shoot. If it doesn't have a target, it does nothing. But if it has a target, it, of course, puts the probe there and fires a projectile there. The, over here, I have this nice big tower of blocks. Whoops. But I also have a pyramid someplace here. I think the pyramid is in the Just Gun scene. Don't save. So here I have my target, my tower. I can specify how many in X and Z and Y I want. And here's another little script, a pyramid that is just something else to blow up. And of course, the B key blows things up. There's also an N key that repels things from your character. If you get stuck someplace, you can N key and repel things. So I'm going to stop sharing there, and I'm going to end the recording. I had a lot of fun with this one, and I hope you do too. Bye.